Welcome back to another episode of the Open Source Cafe. And today we are going to talk about an introduction to cloud native security. Before we get started, I want to give a huge shout out to Saksham for joining us. And Saksham, would you like to tell our viewers a little bit more about yourself and what you do?
Okay, hi everyone. I am Sakshyam Shah, and I currently work as a developer relations engineer at Teleport. For those of you who don't know, Teleport provides a secure and most developer-friendly way to access Kubernetes clusters, databases, SSH and Windows servers, and web application across all environments.
Amazing. And since we're talking about like securities and stuff, it's extremely important when we talk about access management. And in the DevOps bootcamp, we already covered a tutorial on Docker and the Kubernetes part and everything. So we'll be doing more and more videos about how you can utilize Teleport, and check out the links in the description to get started today. But Saksham, can you give us a brief overview as well about what folks can expect from this session?
Sure. So the main objective of today's session is to give a brief overview about cloud native security. So to be specific, so I will be explaining what goes into cloud native security or what it means by when we say cloud native security. So that's the first thing. The second one is I'll be giving a brief differentiation between traditional security and cloud native security. And then finally, I will introduce few of the trends that goes into cloud native security that you have to be familiar with to get started in cloud native security.
Amazing. Looking forward to it. And if you have any questions about this session, make sure you leave those in the comment section below. You can also join the Teleport Slack and join the community. It's amazing, and ask your questions over there. Saksham, let's get started.
An overview to cloud native security. As I mentioned earlier, so the basic agenda is to give you an overview of cloud native security, explain how it compares to traditional security, and I will also be introducing few workflows and tools that enables cloud native security. Okay, so we have to understand what is cloud native. So what is cloud native? So I'm sure most of you already know what is cloud native, but then I can bet that most of you will have a different answer to what is cloud native. So there's a joke in cloud native community that if you ask 10 different people about what is cloud native, you'll probably receive 10 different answers to that question. And it's true because cloud native is such a vast ecosystem. It's moving at a phenomenal pace, and there's lots of things going around in cloud native. So when we speak about cloud native security, we can't understand cloud native security until we understand cloud native itself. So I'll try to be concise in explaining what is cloud native. So bear with me. This definition is not a self-made, and I borrowed it directly from Cloud Native Foundation Charter. So it's closest thing to what the core member and the maintainers explain Cloud Native themselves. So Cloud Native, it empowers to build and run scalable application in modern dynamic environments such as public, private, and hybrid clouds. So that's a core part of cloud native. And it also allows engineers to make high impact changes frequently and predictably with minimum toil. So that's a core part of cloud native. What is, why do you need a cloud native? And how you can build such scalable applications is by building loosely coupled systems that are resilient, manageable, and observable. And you can build resilient, manageable, and observable applications by using containers, service meshes, microservices, and immutable infrastructure with declarative APIs. So that is the core part of cloud native. It empowers you to build a scalable application with a resilient and manageable and observable natures, and using containers, service meshes, and microservices. So what does cloud native look like in practice? So it can be presented with popular 4 C's of cloud native, so that includes first, as a cloud infrastructure. It can be a self-managed data center as well. Then you have Kubernetes clusters. On top of Kubernetes, you have containers, and on top of containers, you have a code. So when we generally speak about cloud native, it's obvious and it's common that most of people think cloud native is Kubernetes only, and which is true in a sense that Kubernetes is the core part of cloud native that kickstarted the whole cloud native ecosystem. And majority of cloud native operations are handled by Kubernetes itself. So Kubernetes, it's a core part of cloud native, but it's still not the only one. And when you think about cloud native, you have to think about all the components that goes into cloud native operations. So when you define cloud native, just think of it as it's a collection of tools and technologies that helps build and run cloud native applications. And Kubernetes is, of course, core part of cloud native. So now we can come to what defining what is cloud native security is. That cloud native security is just a set of security practices applied earlier into each layer of cloud native application delivery process. And it includes both cloud native infrastructure and cloud native application itself. So digging deeper, so when you speak about cloud native security, you have to think about securing the underlying computing infrastructure. So this can be AWS, Google Cloud, Azure, or any public cloud. If your organization is managing self-managed data center, so you have to think about your own data center as well. And it may include physical security also, because if you're the responsible for managing security of your data center, so you have to think about physical security also when you think about cloud native security. And then you have to think about the vast attack surface the public cloud infrastructure have themselves. And they include a security of APIs, configuration APIs. And then you have also have to think about the traditional network security, system security, identity and access management best practices, and of course governance, risks, and compliance. And then when you also have to think about the core infrastructure, which is directly related to Kubernetes itself, since Kubernetes will be installed in the underlying cloud infrastructure data center. So more security emphasis has to be put upon the components that directly related with Kubernetes. For example, you have to think about how to control network access to Kubernetes control plane. So this is not via Kubernetes, but via underlying infrastructure. And you have to think about network access, securing network access to nodes, Kubernetes nodes. And you also have to think about security of Kubernetes access control to cloud providers API itself, because Kubernetes integrates in a much deeper way to your infrastructure. Then you have to think about network access to securing network access to etcd, since every Kubernetes data and configurations are stored in etcd. You have to think about security of etcd as well, and which also includes etc encryption of etcd. Then you have to think about the third one is the Kubernetes cluster itself. So in Kubernetes, most of the management is done via APIs. Of course, securing access to Kubernetes API is one of the biggest thing you have to think about when you think about cloud native security. So these includes applying authentication, authorization using RBAC, ABAC, and also can be applying single sign-on to Kubernetes API. So these are one of the most important part when you think about Kubernetes cluster security. Then after that, of course, secrets management, how the Kubernetes, you store secrets in Kubernetes clusters. Then after that, you have to think about pod security, how the pods are managed. These includes pod admission controls, and also everything that is related to host pod itself. For example, how do you define a namespace to differentiate between different applications that goes into Kubernetes clusters. Then you have to think about, again, quality of service and resource management, because if the resource themselves are not adequate, you might run into problem that affects security. And then lastly, you have to think about security, how you implement and manage TLS or ingress controls to Kubernetes clusters. And the third part is securing container during build and runtime. So going back to our 4 layers of cloud native security. So container is the one that hosts the application. So you have to think about how you manage the whole life cycle of the container you pull and build itself. So these includes container vulnerability scanning, container supply chain security. So how do you build containers? What goes into building your container images? So you have to think about supply chain security as well. And then you have to think about least privileges inside the containers, how the containers are mapped to the underlying Kubernetes clusters. And then you have to also think about container runtime isolation, so that the runtime engine doesn't are the any threats to runtime containers, container runtimes are properly and adequately uh, contained in case of any vulnerability or exploits occur in containers.
No, I believe like the immutable containers also play a role over here. Like once a container is running, for example, so it may be possible to change its contents. Like you can use some package managers or something, and if you modify it, like to include some code that was not like uh, present during the build time, as you mentioned here,
Mhm.
so it's not really possible to scan for your security threats and stuff. So what are your thoughts about like that?
So yeah, so immutable containers is actually a best practices to run containers, regardless of if you think about container security or not, because that's what the container is supposed to be. It's so easier to spin up a new build and spin up a new container. It doesn't make sense to go and edit containers. And then again, yes, if your organization has practice to just go and change container during runtime, it may introduce more severe security threats to it. So yeah, it's not suggested, and the containers, it should be mutable. They should be mutable. Okay, so moving forward, the last thing you have to think about is how to build a secure applications. So of course, if your application itself is not secure, we can guarantee the security of containers, Kubernetes cluster, and underlying infrastructure itself. Because at the end, is the application we want to build and deploy using cloud native solutions, right? So you have to think about secure software development life cycles and coding practices. You have to also think about how do you pull the dependency to your applications. So you have to think about supply chain security and open source dependencies as well. And then you have to implement continuous testing and applying web application security controls. You can begin with OWASP top 10, but in fact, we have to think and cover about all the possible security vulnerabilities that might go into web applications. And then it may include also manual and automated testing such as DAST and SAST as well. So these are the basic things related to securing application. And if you are following with me, then you may think that these thinking about security, the points I have been talking about are actually not that specific to cloud native security. So you have to think, if you think about it, that these recommendations are something that you have to think and apply regardless of you use cloud native solutions or not, right? So it's just that the categorized in the four different spaces so that it helps understand in the cloud native way. Otherwise, these are the security controls you have to practice anyway. So that brings to what's new in cloud native security, right? So when you think about cloud native security, so there are fundamental differences between how you think about traditional security and cloud native security. So starting from infrastructure security, so in traditional security, you have a perimeter-based security that is applied using network firewalls and controls over the location of source and destination of users and systems or application they are accessing. They are usually based on fixed IP addresses or defined to a specific hardware devices. But when you think about cloud native security, you have to think in a zero trust security paradigm that verifies service to service identity, user to service identity. You shouldn't have any implicit trust implied, and each new connections and data transport must be contextually verified. So that's the core differentiate in how you think about cloud native security in terms of infrastructure security. Then coming over to application security. So in traditional security, let's say, for example, your organization builds and deploys two different web applications. So in traditional security, what how the security were implemented is that you have different sets of security requirements and enforcement policies that are different to two different applications. So if there's an application A and application B, both have a different security requirement and security development lifecycle, and that's how you've been deploying building web applications or system applications in traditional security. But when you think about cloud native security, you have to think about how to imply security in a centralized way, so that security requirements are shared across all applications. So when security requirements are shared across all applications, so it makes much easier to understand and manage security, since you can have a uniform way to enforce security at the specific choke points. You can share security hardened libraries, you can share security hardened build process. So it overall increases the security development, the product development in terms of security. So that's a core difference between traditional security and cloud native security when we speak about application development. The second thing is in traditional security, so once the application is developed, you have a specialized and infrequent rollout process. For example, let's go back to the same application A and application B. So application A can have a different and specific rollout requirements, and application B can have used to have different rollout processes. But when you think about cloud native security, all the build and deployment process of different application has to be standardized. So then again, you have a centralized way to enforce security, test for security, and make sure that everything is consistently built and roll out. The final thing about traditional security is that there used to be a joke that whenever a security auditor go and ask a developer about how secure the web application or any software is, the developers they would say that the security model is based upon that no one get access to the underlying operating system, right? So security auditor, they are like, what happens if someone get access to operating system? And developers would say, that's the core part of our security model itself. No one has to get access to the operating system itself. So that's the core part of traditional thinking about how traditional security used to manage application isolations. So it used to be at a virtual machines or operating system and network level. But when you think about cloud native security, you have to think in a way that even if two different applications shares same underlying resources, security, there has to be enough security that the compromise of one application or the underlying resources would not affect the other application. So that is only possible if you think about isolation at the workload level, and this is possible and way easier to implement in cloud native security, because the underlying infrastructure that Kubernetes provides makes it so much easier to isolate application at workload level. So these are the core fundamental differences between traditional and cloud native security in context of application security. Now, there are few, besides the differences, there are few new workflows that is coming up with cloud native security and that is being popularly used. The first one is shifting left. So shifting left means applying security early on in your application delivery, development, and delivery process. So, for example, in the traditional security, you first design the application in terms of application requirement. Then you test the design specification for security. Then if it's passed, you go to different stage and where to build the application. And only after the application is built, you then again go to security teams for security audits. And this is the process we can see in each stage, from development to testing to staging to production. But shifting left means you have to incorporate security consideration before you even draft your first design, right? So first you build a security model, and you design your application based on that, within that model, so that security is incorporated in your application from the design process itself. And similarly, in each stages, you incorporate security way before anything that is to be done. For example, before you test your application, you have to think about security test. When before your product goes to staging, you have to think about security test, or how can you build a secure staging environment. And also, once the staging environment is passed, before it goes to production, you have to think about security again, and has to go via all security testing process before it goes to production. So uh, the one thing, in a summary, one thing shifting left means is building automation process into your whole development lifecycle, so that security is tested in early on in each stage of application development to delivery process. And shifting left, to add more on shifting left, is that it not only enhances security, it also makes it much efficient. For example, if a vulnerability is found once the application is released, there's so much engineering cost and time wasted just to fix the vulnerability itself, and the whole team may have to go back to the design specification itself and change on the process. But if you organization practice shifting left, so that can be content way earlier, that can be like think about way earlier and prevent it way earlier, and you can save all the engineering times and values of your employees early on as well. So shifting left brings value to both in terms of security and efficiency in the application development and delivery process. The second thing that is new workflow to cloud native security is code based configuration and detection patterns. For example, these are infrastructure as a code, configurations as a code, policies as a code, and detection as a code. So what they bring is consistent and standard infrastructure provisioning and deployment workflows. Uh, Configuration as a code, they all, when you can save configurations, detection policies all in a code, you can put them in version control system and easily track change processes as well. These helps maintain immutable infrastructure, and will also help to implement security audit at code level. And the final thing, these code based configuration pattern being, is that they enable you to automate whole security process, since you will be keeping the configurations and management codes in a version control system that can be directly applied to your CI/CD pipelines in each build and delivery process. So it helps for automations, and also, just like a code review security. If your organization practice cloud native security using policy as a code, detection as a code, these configuration can be code reviewed as well. So you can bring many teams and fellow employees over different different uh, different departments, so that they can have an eye on code review of the security configuration itself. The last thing, when you think about cloud native security workflow, is that cloud native security prioritizes for resiliency. So it means that when you think about cloud native security, you have to expect outages, be it given a network outage, server crashes, or even outage due to a cybersecurity breach. So it helps when you think about resilience, it helps to prepare early on to avoid downtime. And this can be achieved by two ways. First is resiliency by following resiliency engineering. So resiliency engineering means you'll the notion of avoiding downtime that will be thought of and implemented early on from the design process itself. So whole application is built in a resilient way. And the second thing is chaos engineering. So once application is built and deployed by implying resiliency engineering, the chaos engineering ensures that what if something is not working as we expected it to be. So chaos engineering brings concept of just avoid bringing in random chaos to your whole application runtime, so that any defects are found early on. So that helps you ensure that in production, any similar scenario, your application will survive. So the last thing about thinking about cloud native security is prioritizing for resiliency. Okay, so that's a gist of what goes into cloud native security. So to summarize, how to get started in cloud native security. First thing is you have to understand that cloud native security covers both cloud native infrastructure and applications. Second, you have to follow modern infrastructure management and application delivery process, so that security requirements and security choke points are shared across all environments in a standard process. The third one is you have to think about full stack shift left security, so that security is incorporated from design to application delivery process, and they are applied early on before any extra code is written. The fourth one is employ modern code-based provisioning and management paradigm. So it helps code-based configuration patterns. They helps to automate security at scale. And finally, when you think about cloud native security, you have to expect downtime and prepare early on with resiliency engineering. So that's it. This is whole summary of overview to cloud native security. I hope it was informational and was valuable to you.
Thanks a lot for the overview, Saksham. It was truly a very informational session. And so let's talk a little bit more about like from your experiences. So how do you make sure that your pods are, say, behaving normally? Can you maybe generalize it in a way that what are some of the best practices that you follow when speaking of like monitoring and stuff?
So, of course, logging in Kubernetes or any system is one of the most important part that helps you implement logging and instrument what is everything that you have configured is working properly as expected. So, for identifying any changes in pods behavior, the first thing is to go about logging in Kubernetes. So first thing is you have to start logging in Kubernetes, and it depends on how you are using Kubernetes cluster. It can be self-managed, or you may be using managed Kubernetes service from, let's say, AWS or Google Cloud. So all of them, the service providers in public cloud infrastructure, they have a good logging infrastructure. So you can directly push the logs to the log correlations systems that are offered by public cloud, and you should implement logging from day one your Kubernetes clusters are deployed.
Thanks a lot for sharing. And when we talk about security, there's, oftentimes there are various tools that folks can make use of. So my question to you is like, what is your view on this? So for example, when we talk about secrets, you're talking about managing secrets. So secrets stored in etcd. And we know that in order to protect that, like that database anyone can access. So to protect that, etcd offers, like you can encrypt your secrets in etcd, but you can also use some external like secret manager, for example. So in which scenario would one want to use some external tools rather than like some inbuilt tools?
Okay, so about this, I always recommend everyone is to get started with what is available. So it depends on the team and resources as well. But for any team sizes, it's always recommended to use the default tools and services that's available. So it might make sense for using external tools if, for let's say, certain edge cases requires it, or certain compliance requirements ask for it. But until that's not the case, I usually suggest to go with default and readily available tools, because the more tools you add to your infrastructure component, you are increasing complexity of your infrastructure. And complexity, it's not good when we think about security, right? So unless some edge cases requirements ask for different secrets manager, you should be using the built-in tools itself. The one other thing when you have to use external tools is that, of course, when you use Kubernetes readily available tools to manage secrets, manage encryption, where do you store the encryption keys? And I think these are some of the few cases where you can use external tools, where you can securely keep the encryption keys. Other than that, encryptions are you can use the built-in functions as well.
Amazing. Well, thanks a lot for sharing, Saksham. And I see the presentation also had blog links and resources links, so it's going to be extremely helpful for folks. And thanks everyone for watching. Make sure to check out the links in the description to learn more about teleport and cloud native stuff. And we'll see you in the next one. Have a great day. Bye.
Okay, bye.